after calling on the data, we use the comma and then say this particular variable we want to actually tabulate is the physical variable or the column. So if you run this, you can see it has divided it for us. So there are two groups, those that are physically active and those that are not physically active. So we have those that are not physically active, this is the no, and those that are physically active, this has yes. So 1,844 people were not physically active. Why 1,998 were physically active? So now with this count function, we now have an insight of what is happening in this physical active data. We can decide to also use the same thing for the health rating variable. So if we run this, you can see, remember when we tabulated this distinct, it gives us the distinct character, but it didn't count to tell us how many of them. So the count function is not just grouping it, at the same time it's giving us the count. So you can see them down here. Now this is why I'm telling you the console is where our outputs are given for scripts. So gradually you come to understand this as time goes. So next, let's select columns. Remember we are on data manipulation, and there's a particular this thing with dplyr. This dplyr is a particular library we use in tidyverse. So when we load the tidyverse package automatically, it has this dplyr because the tidyverse has more than 6 packages or so, as I said before. So it's a particular package found inside the tidyverse. So if you load the tidyverse, it just helps you with other packages. One of very, very important package in our tidyverse. You can Google it, or you can check it later. So now we want to actually select a particular column. Yeah.
These distinct, and some persons are curious to know, is it the same thing? Does it serve the same purpose that distinct and count serve in Excel?
Okay, distinct and count serve in Excel?
Yeah.
Yes, to some extent, yes. But I think the way Excel is being formatted will not be the same way R is formatted. But they actually have the same plans of bringing out the same results. But it's just the syntax how is actually that might differ. You understand? Mm-hmm. Okay. So now we go to selecting columns. Remember, we have 9 variables here, or 9 columns. I know. Let me just make it straight. Anytime you hear me say variables, just not talking about column. Then when you hear me say observations, not talking about rows. So because in research, what they understand is variables and observations. This column and rows is more like a technical part, or let's say more of a computer algorithm or computer word. So in terms of research, it's just best to use variables and observations, which is best. Okay. So now we want to just select two. We want to select 2 variables, which is 2 columns. And then they said, let us select just insomnia and smoke. 100 people that's the smoke variable. Those people are smokers and those that are not smokers, which is what is made up in this particular smoke 100. So we just want to select 2 particular column, insomnia and smoke in 100. We don't need the remaining 7. So for us to select just those 2, we apply the select function. So select function is used to select columns. Always remember to put your data, because as I said before, it's not just one data that is here, there are 2 datas, and you can have more than 2 or 3 or 4, depending on when you want to start running complex analysis. So always remember to put your data first, and then comma. After you comma, you can now say, okay, call the remaining variables you want to select. So you want to call the insomnia variable and then the smoke variable. And then after calling it, you want to assign it. Remember this assignment operator, you want to now assign it to a particular object called select data, just for you to understand that you have selected this particular data. So it's always good to use objects to have a better and easy understanding. It's always good to have an object when you are, but it's always good to have unnecessary objects. Just have objects for better understanding and for reproducible research or projects. So let's assign this. So now you see, it's no more 9, it's now 2 because selected 2. So if we click on this selected data now, you can now see we have only insomnia and smoke. So now we don't want to work with the remaining 7, we just want to work with these 2. Fine. So now we now see some data manipulation functions happening in real life. Okay. So going to the next one, let us create a contingency table. A contingency table. For those people that are good with research and statistics, I think for you to actually run a chi-square test, you need to create a contingency table, tabulate your data first of all. And we use chi-square for understanding relationship between 2 categorical variables. Yeah. So now I'll introduce you to a new syntax in R called the pipe. We call this the pipe or the piping syntax. So this piping, so people might choose, let me write percentage and then greater than and then percentage. Fine for beginners, but it's always advisable to be swift with your code. So there is a particular keyboard shortcut we use for that, which is Control, Shift, and M. We should use for this piping variable. I'll come to explain to you why we use the pipe variable and why it's very good. It's a very good function developed for the developed in the tidyverse, this is why tidyverse is very important. So this just makes the code very easy. So let me just give you a simple analogy so you understand what is happening here. So remember that we have a particular data set now called selected data. Now I've created a data set. Fine. So now we want to say select data set. So we say we want to take this particular selected data set and then create a table with it. That's what we want to do. So we want to collect this particular data set and then create a table. It's just 2. And remember, because we want to plot a contingency table. So this is where critical thinking comes in as an analyst or a scientist. You need to be thinking critically of how you can actually make your code work for you and the rest. So make life easy for you. So now you have selected 2 data sets. And remember, the chi-square involves relationship between 2 categorical variables, and it's those 2 categorical variables you've selected. So you just say, now take this selected data and then create a table. So now let me make it easy for you to understand. Let's forget about these codes here. Let's say select this particular data and create a table. Look what we're having down here. Look what we're having here. It has tabulated these 2 particular variables for us. So we have here now is it has decided to apply insomnia, which is the first one we see here. It has taken the first row, the first column, and made it a row. Tabulated it in form of a row, thereby grading it into no and yes. And then taking the smoke column and making it in form of the variable section. So it's trying to tell us now that, remember, if you add all these things here, it will give us 3,842 observations. If you add 165, 1173, 54, and 446, if you add all these numbers, it will give us this particular thing here. But now it has divided it for us now because we are creating a contingency table. It has now divided it and now told us that for those people who had no insomnia or who didn't experience insomnia, 1,675 of them were non-smokers, while the remaining 1,170 of them were smokers. And then for those people that had insomnia, they found out that 446 of them were non-smokers, and then the remaining ones are smokers. So it has created a contingency table for us just by using this pipe function. So this pipe function means it's just like taking a particular data in front of it and then applying a function at the back. That's what we did here. So it said take this particular data we have selected and then create a table, a contingency table for us. So let us go back again and see why I added this code. So then after creating the table, you're not saying it, after creating that table, apply another pipe function, that is take that table you have created and then make a chi-square test for us. So you see, it has given us a chi-square test. That's why we say R was built for statisticians. So with just few lines of code, we have created, we have performed the chi-square test with insomnia and the smoke column. So now it's trying to tell us that the result is trying to. I don't want to go deep into it, but I think the p-value is very low, which is statistically significant. So we can say there is a relationship between insomnia and smoking. Fine. Okay. So let's go to renaming columns. Now we want to rename columns. So for example, they said rename the serial number to ID. Let's go back to our data column, which is the most important one. So we have this serial number here. We want to rename it to ID column instead of serial number. So for us to rename it, always use a function called rename. Remember, always have the data set in front at first, and then we'll now apply the new name. So the new name comes first. So we want to name it ID, and then the old name is what? Serial no. So if you run this now, it have changed. So let us check, and I created an object. You can decide to just run this line of code without assigning an object. We'll see it here. So you see that serial number now has changed to ID codes. Or if you want to see it on this place like this, you come here and run it together with this without just selecting here. Because if you select only here, it will run here. But if you just run everything, means you want to run everything here. You just come here and run everything. It has created a data set here called rename data. So you see now that data has changed to ID instead of serial number. So it's a simple way of renaming your column if you don't like how it's named or you want to change it to a better naming. Still under data manipulations. Okay. So the next one is filter. We want to filter data. So here we say, let us filter the data where the BMI variables are greater than 30. So to apply this, we apply the filter function, put the data, which is this, and then comma, and then the column. The column is what? BMI. So we want BMI. We want the filter data where BMI is greater than 30. When we run this function, it will bring out a new data set, and this data set is a filter data set. If you click on it, so it's showing us, you can see now it has reduced. It's no more 3,842 observations. It has reduced to 1,390 because of what? We only wanted the data, and we wanted where the BMI. We wanted data where the BMI is greater than 30. So it's only selecting the data set of where the BMI is greater than 30. So if you take a look at this now, you know that all the values in this variable are greater than 30. So this is how we can filter data, just a simple one. In the main course, we'll come to understand how we can use the greater than or equals to sign, how we can use the or, how we can use the and sign. So there are other operators we can use to filter data. But I'm just showing you a brief of what you can do with R. So the next, now we want to create a new column. In this part, we use a particular function called mutate, which is also a function from the tidyverse. So let's say we want to actually apply the pause and the BMI column. So remember here in our data set column, we have pause here, we have BMI. So we want to multiply these two columns. We just want to multiply it. In a situation, this is just for you to understand how R works. Sometimes you might have height, or you have weight. So they will tell you, okay, derive the BMI from the weight and height. So it's left for you to apply the mathematics behind it. So for you to apply that mathematics behind it, there's a function we use which is called mutate. So just like we applied for other ones, you always put the data, the comma, and then we say the new column we want. So let us call this new column BMI underscore pause. And then we'd say, okay, now we have the new column. So this new column should comprise of, so we'll now say equals to, so we'll call the name of the column we want to manipulate. So the first one is the pause column, or the BMI, as how you want to put it. You can put anyone first or second. So now if we run this now, it will give us a new data set with a new variable called BM underscore pause. And you see that our data set will no longer have 9 variables, but it will have 10 variables. So let's run this. So you can see it's a mutated data is now having 10 variables. So let's open it and check what is happening here. So you see the BMI underscore pause has created that column because it multiplied BMI by this. So if you times 70 by 32.2, this is what you get. Likewise for other ones. So now you now come to understand why it's actually very useful for data analysis. Now let me go back to what Somto asked. Sorry. You know, he asked me, why do we have to actually take this and then put this at the first? I was trying to make him understand, we're trying to group them together. And that's why when we group them together, we can actually assign them to a new object. So that when we're actually running manipulations or analysis, we want to start writing all this long thing or copying this long code. You can just type in this number because I've assigned this thing to become this, and just it give us our result. So it's the same kind of principle we use here. So you understand? So it's the same kind of principle we still use here, both for the filter data, for the renamed data, for the mutated data, the same kind of principle. So this is a variable, pause, BMI2 is also a variable. So you don't need to start writing all the values in each of these columns. You just pick the column and run your code, and it gives you tabulates all the results for you automatically. As you can see it here. Okay, so data visualization with ggplot. So ggplot2 is also a tidyverse package, just like we have it here for dplyr for manipulation. So the ggplot2 is for visualization. So we see ggplot2. So I'm just going to this one. You need to go in depth for you to understand what is happening. But I just put this up so that you can see what is happening. Later on, I can send this file across to the group. So you can have the file. Then if you install your R, you can open it on your R and check what is happening there. So this is it. So you call the function ggplot, call the data, the a-axis. I don't want to go deep into it, but in the advanced program, we'll come to understand how to use ggplot. So let's change this now. They say let's create a basic scatter plot for total cholesterol and diastolic blood pressure. So let's change this to total cholesterol, which is the variable. Remember, we have a variable called total cholesterol, and we have BPD and diastolic average, so the average diastolic blood pressure. So let's change this one here to BP dia AVE. So always make sure your variables are matching with your codes, because if you put something that is not meant to be there, it will flag an error. So if we run this particular line of code, let's just run. So we want to create a scatter plot. So let's just run this particular line of code down to the geom point. So if we run this, you can see, remember I told you here is for our graphs. So now we're trying to understand, we're getting to see what is happening gradually. Remember here was for our files, this section was for our graph. So basically just know that your graphs will always be populated here. So we can expand to see what is happening. Or if you don't want to use the expand, if you don't want to just drag and navigate that way, you can just come here and click zoom. You can see what is happening here. So you see it has created a scatter plot for us. And it has, remember what we used here. We have the X, that's the X-axis. The X-axis, we have the total cholesterol, which is down here. On the Y-axis, we have the BP diastolic average. So once you check if there's a correlation between total cholesterol or diastolic blood pressure and total cholesterol, whether as the total cholesterol increases or reduces, the diastolic blood pressure increases or reduces. So that is the point of creating a scatter plot. It's used for actually visualizing two numeric or continuous variables. So remember, I just selected this line of code and ran, and it showed us this. Remember, you can always highlight and select. But now I want to now include a linear regression line to know what is happening. So I'll add this code. I'll stop here. So you see it has created a line for us. So you can see, I think it's showing us a positive correlation, which means as total cholesterol increases, your diastolic blood pressure tends to increase, which is good. So we see what is happening here. So we want to now add another one. I'm just taking it one by one so you understand, but I'll still go deeper in the advanced course. We want to add another one. This one is to the team. We don't want to see these grid lines. It's not looking fine. So we want to make it just pure white. So there's a function called team classic. We have the team, we have other team backgrounds. You can see those grid lines left. So you can see how R is beautiful for making plots. So now we want to edit this. This is not a good way of actually naming a graph. You need to actually label it properly. So we use the function labs. So this labs means label. So we put the function labs, and then we apply inside the labs function. We'll call on the argument called title. We change the title to relationship between cholesterol and diastole. And then we want the x-axis to be called diastole, and we want this y-axis to be called total cholesterol. We want this x-axis to be called total cholesterol instead of, I think this should be diastole. Okay, so let's run the whole line of code. So when we run the whole kind of code, you can zoom it now. You see that header, that title, relationship between cholesterol and diastole. You have the diastole on the y, and we have the total cholesterol on the x-axis. So it is a beautiful scatter plot. We can change the color. Here you can decide to change it to, let's say green. Or let's use blue. Sorry. You can change it to any color you want. Any color you want. So it's good to use colors that are readable whenever you are creating a graph. Just change it to blue. So this is it. Okay. So the next is getting closer to the end. So I'm just going to show you how to run a simple linear regression. It's not going to take much time. You can see, as I told you, R is just built for statistics, just like how we run the chi-square here. You can apply that for t-test and for ANOVA, but I'm not going to talk on all the tests. So this is just the last test, a simple linear regression, which is a kind of machine learning algorithm. So and the principle is based on the ordinary least squares. So it's just a simple function, and it's inbuilt in R, just the LM function, which stands for linear, and then we'll put the brackets. So we have to get the one on the y-axis. First, you have to apply it here. You can put the variable here is what AP underscore dia underscore AVE, and then the X we have dot cholesterol, and then after that you apply your data, you check your data. So what's now the data? Data we have here, now the data is data. So we just put data. And then when we run this particular line, we have the coefficients here. If you decide to run everything, it has created an object here. OLS model, remember here is to assign object. So let us check the summary of the object. So this one gives us everything, both the adjusted arrow, the arrow square, the coefficient, the intercept, everything. So we can discuss on how to understand how to actually explain linear models in later course. So this is it. So we can that this is a positive. This is a statistical significant test. You can see the p-values. I'm showing us that yes, total cholesterol has a relationship with diastolic blood pressure, statistically significant. Even the intercept is statistically significant. But when even the overall p-value too is also statistically significant, showing us that yes, there's a relationship between this one, which is a positive relationship. And from the line, from the visualization, you can actually see that yes, there's a positive relationship between these two. But now, if they say, okay, now, can we use this model to predict cholesterol, to predict diastole, that is people's diastolic blood pressure? using their cholesterol level. Can we use this model? As an analyst, scientist, or a researcher, they can ask you, can we use this model? So this is what will tell you if this model is good or not, the R square, the adjusted R. So it's showing us that it's a very poor model. So this is 2% or approximately 3%. It's showing us that the model fits, the data fits this model with just 3%. So this is not a good model. So you can't use this particular data or this particular model you use from this data to actually make predictions. Even though it's statistically significant, there's no proof that we can use it to make machine learning predictions or make insightful predictions going forward. So at least you should be aiming for over 70 to 80% accuracy, R square. So this is a very poor model, even though it's statistically significant. So there are many things we need to understand going forward in statistics. So data analysis is not just understanding how to code, but you need to understand how to tell story with your code, how you can actually get insights, how you can actually make better decisions, and also help your community or your employers understand how they can use their data efficiently. So you need to know statistics. I always advise people to understand what's happening in statistics before rushing to the languages and the rest. Statistics is like the main thing. Probability, other things you need to know, and then understand some concept of research before you say, okay, let me now dive into learning how to actually apply this my knowledge using statistical tools like R or Python, SPSS, and the rest. So this is it. Okay, so for us to clear the console, we want to clear our environment. We have some data at the end of our work. We also want to clear our data here. We don't want to leave all these things here because someone can come and look at it like, I don't understand what's happening here. So let's just clear it. And then in case you want to restart from the beginning to teach someone what is happening in your code or reproduce it, it's always good to clear your environment. So to clear it, there's a code we use. So we use the RM, stands for remove. And then we'll put list. This list means the list of this code equals to ls in bracket again, and then finally the close bracket. So when we run this, it clears up the environment. So if we want to actually clear what we have down here, we don't need all this plenty output here. You can just type Control L on our keyboard and everything is efficiently. So just for you to understand that the script provided here was just a brief introduction to how we can use R for running research. But with practice, we'll be able to perform complex data analysis and create insightful visualization. So on the chat, I think someone asked, it's one downloading tidyverse on Google. Yeah, so no, you don't need to download the tidyverse on Google. What you just need to do, you need to always, first of all, install the R programming language. After installing the R programming language, you install the rstudio, which is the integrated development environment where we put our codes. So after that, let me share my screen again. So I think I'm still sharing. Okay. So let me go back. So as I said before, there's a function called install.packages. So this particular tidyverse is the main package we use to make life in R very easy. If not, you might end up using basic R function, and basic R function can be quite complex. So this one is just very good for researchers that don't have prior programming experience or knowledge. So the tidyverse makes life easy. That's why you see I was using a lot of functions like rename, select, mutate, count. All those things are tidyverse functions. So for you to actually run this particular function, this particular package, you need to install it. Or if you don't want to go through that process, you can come to packages here. Let me expand here. So we have what they call packages here. I told you I have an archive of packages, thousands of packages. So you can come to packages and click on this place, they wrote install. So when you click on the package you want to install, so you call it tidyverse. So you see it here. So I already have it, so I don't need to install it again. So once you click install, it automatically installs. You understand? And then it will start installing. You start seeing some things on this your console. It will start telling you it's installing. But before it's installing, you need to be online. It doesn't install locally without the internet. So you need to be online while installing packages. You can load the library offline, but for you to install any package, you need to be online. So after the installation, you can come to this place now and search for the package you have installed, tidyverse. So for you to load it, there is library. Remember here we talked on library. Remember we talked on to load the tidyverse, you need to use the library function. But if you don't use the library function, you can just come here and tick the tidyverse. So when you tick it, because I already loaded it, it's already ticked. So you can just come here and tick it. So it depends on the one that is faster for you. Will you prefer to type the code in and run it immediately, or you want to come here, install it? After installing, you come here, type the particular package you install, and then you tick it to load the library. So you see why I tell you R is one of the most flexible IDE. So with time you get to like it, but you have to first of all understand what is happening in it first. So it's just quite interesting using R to run some analysis. So let me go back to, I think some people asked another question. How do you load the tidyverse package? Okay, I think I explained that already. So you can just click on that particular package after installing tidyverse, and just click on this. And once you click on it, like now it's already loaded, so it's ticked. So when you click on it, it's ticked, and then you can start using it on your PC. Okay. All right.
Analysis journey. So this is just like a tip of the iceberg, okay, of our 2 months program. I.e., some of you that joined the call that we are part of the cohort and cohort 2 for SPSS session. I'm sure you should know what to expect. So over the next 2 months, we'll be engaging deep in SPSS, R, and the research. So these are 3 areas we'll be focused on, and of which we will be there to guide you through every step that you will be needing to be a good research analyst using these tools. And if you will want to be part of the 2 months training as well, the forms will be in the group chat. So that's it for this month's live session. Innocent, we can see you. Thank you very much. Chief Chibuzo, we can see you. Thank you for joining. Esther, we can see you. We didn't capture. Thank you very much. Ajayi, we can see you, please. Thank you very much. And our tutor for tonight, it's been an amazing session. We love your teaching, sir.
Yeah, thank you very much. I'm pleased to have you again.
We can see Manuela, Ido Samuel, our public relations. Thank you very much. Kuma has been with us since yesterday. And Nomba Davidson and Ichidioke. Thank you very much, everyone. All sessions on research, on SPSS, on our and other research tools to improve our community. And do have a good night,